Hello everyone, in this video, we will share our experience during the industrial site visit to Samamahir Sdn Bhd, a metal casting company based in Johor. This is part of our assignment for MEM360. This is the list of content that will be presented by us in this video. Our group consists of 4 members. First is Nurmaisar Humaira. Second, Siti Nur Alia Farhana. Third, Sufika bin Safar, and last but not least, Muhammad Afif Duha. And this is the distribution of work among our group members for this video. So, what are you waiting for? Let's go with us. Samamahir is located in Masai Johor, and it only took us 40 minutes to get there from our campus. This company also has over 52 years of experience in casting and engineering. They produce high-quality metal parts using materials like aluminium, cast iron and steel, and also offer CNC machining service. This is our group photo with the Managing Director, Mr. Tan Sri Roy Tan. He welcomed us personally and shared a bit about the company's background and visions. Samamahir produce a wide range of metal components for industries like automotive, marine and machinery. Some of their key products include pump housing, engine brackets, valve bodies and other custom case parts made from aluminium, ductile iron and zinc alloy. The sand casting process involves several steps: pattern making, molding, cord insertions, melting and pouring, cooling and finishing. Among these, we would like to highlight the melting and pouring stage, which we observe closely during our visit. At Samamahir, metal materials like aluminium or ductile iron are melted using an induction furnace. The temperature is carefully controlled to ensure the metal reaches its proper molten state without impurities. Once fully melted, the hot liquid metal is poured into sand mold through a gating system. This step must be done with precision and safety, as the metal is extremely hot and must flow smoothly to fill every part of the mold cavity. After pouring, the metal is left to cool before moving on to the next stage, checkout and finishing. We also had the chance to view the finished cast product at their showcase area, which helped us see the real outcome of the process.
The first one is personal protective equipment, which is also known as PPE. The most important equipment while casting is respiratory mask to avoid from inhaling toxic gases produced by the molten metal. Safety glove also needed to avoid from burn while handling with molten metal, while safety boot help from any foot injury. Proper handling of molten metal. The first one is use controlled pouring to avoid overpour to the molten metal into the mold. Pour molten metal slowly to avoid splashing into workspace and avoid any accident from happen. Make sure to keep molten metal hot by stirring the molten metal continuously. And the last one is proper ventilation and fuming system. The first one is make sure there is proper exhaust system near the workspace so that the gas can escape to the air. And the second one is most casting process is done in an open area so that toxic gas is released directly. In casting, the design concept refers to how a part is planned and shaped to ensure it can be cast efficiently, safely and with high quality. Cores are used to make internal holes or cavities. It must be designed so they can be replaced securely, don't shift during pouring and can be removed after solidification. The gating system is the network of passage that directs the molten metal into the mold cavity. The function of gating system is controls metal flow speed and direction inside the mold, minimize turbulence which reduce gas entrapment and oxidation. It also helps trap impurities by placing filters or wells, and it also reduces chance of cold shut and misrun. Material selection is one of the most important steps in casting design. Each material has different properties that will affect the result of the finished product. The type of metal or alloy that we choose will affect our castability, which is how well it flows and fills the mold. Secondly, it will affect mechanical properties such as strength, hardness and toughness. It will also affect the thermal properties, which is melting point and thermal expansion. Quality assurance, or known as QA, in casting ensures that the final cast product match the required dimension. It also free from defects, meet mechanical and material properties, and lastly, performs well in its intended application. The first one is pattern and mold inspection. It is a need to check that patterns and mold are clean, correctly shaped and not damaged, or it will affect the quality of the product. It also ensures proper dimension, draft angle and surface finish to the product. The first one, post-casting inspection. After the casting has cooled and solidified, visual inspection are done to look for visible defects such as cracks and misruns. Secondly, dimensional inspection that use calipers, micrometers or gauge to ensure dimension match design tolerance. Thirdly, non-destructive testing NDT such as X-ray, ultrasonic and dye penetration tests. Lastly, mechanical testing if destructive testing is allowed, such as hardness test, tensile strength test and impact test.
After listening to the explanation and observing the entire process at the factory, there were several problems faced during the metal casting process. Blowholes are one of the problems faced in the sand casting process. They occur when gas or air become trapped inside the molten metal as it solidifies. When molten metal is poured into a green sand mold, the extremely high temperature causes the moisture in the sand to evaporate into a steam. Organic materials such as bentonite and carbon in the sand also decompose under the heat, producing gases like carbon dioxide and carbon monoxide. These gases and steam are supposed to escape through the vent provided in the mold. However, if the ventilation is insufficient or become blocked, the gases cannot escape properly. Additionally, if the pouring rate is too fast, the molten metal can seal off the air passage before the gases have to change to exit, causing them to become trapped. Once the metal solidifies, these trapped gas from small cavities known as blowholes. They present weakness the mechanical strength of the final product and may cause surface defect. Another problem faced is cold shot. This defect occurs when two streams of molten metal meet because fail to fuse properly, usually because the metal has already begun to cool before they join. Even if there is only a single main stream poured through one gate, cold shot can still happen. This is because inside the mold, the metal flow may split or change direction before meeting again. If the metal has specially solidified, when the stream reunite, they won't bond well, resulting in a visible line or crack known as a cold shot. The suggestion to overcome this problem is use the hot chamber die casting because it offers more controlled and efficient approach. This method uses high pressure to inject molten metal into a metal mold and is ideal for metals with a low melting point like zinc and magnesium. The process begins with the molten metal stored in a built-in furnace. The metal flows into a gooseneck, a component that connects the furnace to the injection system. A hydraulic plunger then forces the molten metal through the gooseneck and the nozzle into the die cavity at a high pressure, typically between 700 and 5000 psi. This pressure is maintained until the metal fully solidifies. After solidification, the die opens and the final project is ejected using ejector pin. The die is then lubricated and closed for the next cycle. This process helps to minimize problems faced like blowholes and cold shot, since the system is sealed and uses a solid metal die. This chance of air getting trapped are much lower. In addition, venting system and sometimes a vacuum assistance remove any remaining air before injection. This reduces the likelihood blowhole forming. Cold shot defects are also less likely because the molten metal is injected consistently at a high temperature and pressure, ensuring a fast, even flow throughout the die cavity. As a result, the risk of two metal streams meeting while partially solidified is significantly reduced.
Now it's part how the company overcomes the problem. At Sama Mahe Company, the team takes a systematic approach to solving casting problems. They begin by identifying the symptoms during or after production, then trace them back to the root cause of the defect. One common issue faced by Sama Mahe Company during the casting process is gas porosity. This defect refers to tiny gas bubbles trapped within the metal during solidification, weakening the final product. To solve this, the company takes preventive measures such as using clean and dry metal alloy to avoid hydrogen gas formation. They also carefully control the smelting temperature to reduce the risk of overheating and gas entrapment. Another issue is shrinkage porosity caused by metal contracting during cooling. To address this, the company selects materials that suit their system and continuously improve their casting process for better solidification. Sama Mahe specializes in sand casting, die casting and works with both ferrous and non-ferrous metals like zinc, tin, and aluminium. Currently, one of their major products is a sculpture made from cast iron designed for the National Garden in Singapore. However, their casting capabilities can be expanded further. For example, in the automotive industry, they have the potential to produce engine blocks and brake components. In the plumbing sector, they could manufacture pipe fittings like elbow and valve bodies. These products are highly compatible with the existing materials and machinery. While Sama Mahe already operates with advanced tools, some parts of their sand casting process remain manual or semi-manual. This can lead to product inconsistency and slower output. To improve this, the company could invest in automated molding and sand compaction machine. The machine would increase mold quality consistency, reduce human error, and significantly boost production speed. Another area for improvement is energy consumption. The current induction furnace may be consuming more power and melting metal less efficiently. Upgrading to modern, energy-efficient furnace with precise temperature control would save energy costs, lower carbon emission, and result in better quality metal during casting. Lastly, Sama Mahe production layout can be optimized. Currently, there's a long distance between the casting, machining, and inspection areas, which reduce overall efficiency. By redesigning the layout to minimize material movement, the company can reduce production time and improve productivity, aligning better with lean manufacturing practice. With these solutions and improvements, Sama Mahe Company is well positioned to grow further in the manufacturing industry while maintaining high standards of quality and efficiency.
And that wraps up our industrial site visit. It was an eye-opening experience that helped us see how and what we learned in class is applied in the real world. From observing the workflow to understanding safety measures and technology in action, it was definitely a meaningful visit. Thanks for joining us through this recap. We hope you find it interesting and informative. Thank you!